Hello. Yes, good afternoon, all. I hope that I am audible and the screen is visible.
Yes,
Yes,
sir.
sir.
Fine. So now we start with the prompt engineering stuff. This course actually, you are not, you will not be able to access this course, but through this course, I will try to explain some of the concept related to prompt engineering. The course title is Building LLM Application with Prompt Engineering. Basically, this is divided into several parts. In the first part, like basic introduction to prompting is there. After that, chains are explained. Then prompting with messages, structured output, and tools. These are the content of the today's session. So here I am just opening all these things. Okay. So at any point in time, if you are having any difficulty or any doubt, then just feel free to interrupt me. We will have the discussion, and then we will see after that. Yeah, this is nothing but the various portion of the section. For example, this is the first one, like introduction to prompting. This section one in left hand side here we can see. Then second one is nothing but talks about LCEL, LangChain expression language, runnables and chain. Section 3 talks about like prompting with messages. Section 4 is about structured output, and section 5 is about tool use and agent. Fine. Now here we are in the first part. This is nothing but the related to first part. For example, first we will have a look at NVIDIA NIM, which is nothing but neural inferencing module for prompt engineering. How can we use NVIDIA NIM for interacting with LLM, right? This is notebook number 11. Hello World with OpenAI library. So once again, we will have a look at how can we interact with LLM with the help of OpenAI library. This is notebook number 12. Then hello world with LangChain. So LangChain is a tool. With the help of this tool, how can we interact with the LLM, and how like what is the difference between interaction of with LLM through OpenAI API and through LangChain. Then next one is streaming and batching is there. So we will see how can we stream the model response and how can we batch the multiple queries. Then next we are having iterative prompt development in the notebook number 15. And lastly, in the last notebook, we are having this prompt template. Now we will try to see these notebooks one by one. Fine. So this is nothing but the first one. Here just we will have a look at what is NVIDIA NIM and the API catalogs. Basically, here we will see with the help of various API catalogs, how can we conduct the prompt engineering. First and foremost thing is that we need to understand like prompting and prompt engineering. See, basically, we need to interact with LLM. For example, if you ask something to Chat GPT or Grok or any other such platform, for example, you can say Gemini, etc. Here you would be interacting with LLM as an end user. Okay, but here this is not the case. Here we need to interact with LLM just as a programmer, but not as an end user. It is nothing but the formal definition of NVIDIA NIM. It is nothing but easy to use a set of microservices which are designed for secure, reliable deployment of high performance AI model across data center, cloud, and workstations. Right. This is nothing but NVIDIA API catalog. See, you can click on this NVIDIA API catalog. So here you will get all such models, model card, how we can use this model in our applications, etc. All these details are there. You can search any model related to vision, vision design, retrieval, speech, biology, etc. Here, mostly in this framework, we would be using Llama 3.1 8B instruct model. But here in this NVIDIA API catalog, you will find almost all the models which are available over here. This is nothing but the course environment. Mostly we would be using this model, Llama 3.1 8B instruct model. So 3.1 is nothing but the version number. 8B stands for 8 billion parameters are there in that model, and it is instruction tuned model launched by Meta. This is nothing but the Neem deployment cycle. First, we need to use run Neem, Docker run. Then we will have this Docker container download. Now we need to check whether the model is available on local file system or not. And if it is available on local file system, then we can run the model, or otherwise we first need to download the model from NGC, and then we can use all this OpenAI compliant. Fine. Local Neem deployment has several benefits. And what are the benefits? First one is speed. Second one, costing is cheaper. Second one, data privacy and customization and more control is provided when Neem is running locally. Now, this is the thing here. We would be using OpenAI API, and with the help of this OpenAI API, these are the objectives. First, we need to set up and use OpenAI library. Then we will see text completion using Llama 3.1 8B instruct model. We will see how can we interpret and utilize API responses and understand the importance of using chat completion endpoints and all. So this is nothing but the import. The first thing we need to import the OpenAI. Here we would be using first importing this OpenAI. The next step is to set up an OpenAI client. For setting up an OpenAI client, we need like two things. First one, we should have this base URL. We should have this base URL and we should have API keys. But here Neem is running locally, so here we can provide any random arbitrary key, but the base URL is important. This is my base URL and API key. Once we have defined this base URL and API key, then we can call this like OpenAI class. Client is nothing but the instance of this OpenAI. Here we need to provide base URL and API key. So this is the client. Now with the help of this client, we will be interacting with the LLM. We will see which are the various models available for us now in this environment specifically. These are the models. Fine. How can you understand like what you can understand from this model? See, actually, lot many things are there. Actually, all this is nothing but the metadata. But anyway, we are not interested in all this metadata, so we can just print the name of the model, which model is available over here. So we can access the name of the model from this. This is the model. Next, we need to make a simple chat completion request. We need to make a chat completion request. So what do we mean by that? This is my model, Meta Llama 3.1 8B instruct model. Fine. And after that, this is the prompt. Here I am asking something to LLM. What I'm asking? Tell me a fun fact about space. This is the prompt and this is the model. Now I need to get the response, and for that I need to write chat completion. Chat completion create. Here I need to provide what is my model and what is my message. So here just have a look. This is nothing but the model and prompt I am defining, and this is I am generating or collecting the response with the help of this client which I have just created now.
Excuse me, sir.
Hello.
Excuse me, sir.
Yes.
Sir, I think your screen is not visible.
Okay, fine.
And sir, one more question. Do we require any code for opening this course? I think today we are not.
No, actually, we are currently I am not having any code. Like if you want, then I can generate the code for you and I can share later on.
Okay, it would be better, I think, for
Yes,
the
yes, fine. So we would be floating one Google form, like how many of you are interested in accessing this course, and based upon the number of count, I can just generate the event code, because we need to tell to NVIDIA like this much participants are there who are interested in uh, accessing this particular course. Once once they generate the event code for any specific date, then you need to use the event code on that day itself, and then you can access this in your dashboard.
Thank you, sir. Thank you.
Now see, this is the response. Here with this response, lot many other informations are there, so we are not interested in this response. We are simply interested in the content of this response. Okay, so this is the content. Here is a fun fact about space. So what we had asked to this LLM, we had asked this: tell me a fun fact about space. Which model I am using? Llama 3.18b instruct model. So I am having this client. With the help of this client, I am interacting with this model. With the help of this client, I am interacting with this model. This client is nothing but the OpenAI instance. This client is nothing but the OpenAI instance, and I am using this chat completion. I am using this chat completion, right? This is how you can interact with the LLM uh, with the help of OpenAI APIs. Fine. We are having some more example for this. For example, this is my prompt. Like, what is the OpenAI API? Now this is the response, like client.chat completion create. Now this is the response. Once again, I am interested in the actual response, not in the metadata. So here they have just printed this about OpenAI APIs, right? Now we need to differentiate between completion and chat completion. See here what we were using here. Here we are using chat completion, but instead of chat completion, you might have used completion also. There is a difference between completion and chat completion. In chat completion, it take care of the conversational history also. Okay, it acts just like a chat. uh, First I am saying, then some other AI is saying something, then once again I am saying. Okay, so all the histories are also considered while giving the response. But instead, in comparison with this chat completion, if we talk about completion only, so completion is just like question answer. Just put the question, you get the answer. Put the another question, you get the answer. The context of the previous questions are not taken into consideration. I hope that the meaning is clear between completion and chat completion. Next one is this. Once again, we will see Hello World with LangChain. See, so far we have seen that we can use this OpenAI APIs for all this conversation, or for interacting with LLM. This time we would be using LLM. Sorry, this time we would be using LangChain, which is just a sophisticated tool and very easy to use tool for interacting with LLM. Here we just need to understand the difference between like interaction using OpenAI API and interaction using LangChain. In both the interaction, we are interacting with that LLM only. Here, first thing that we need to import is this chat NVIDIA. It is a class. From this package, we are importing this class. Once again, I need to provide this base URL, model, and LLM. LLM is nothing but the instance of this chat NVIDIA class. Here, I need to provide the base URL. I need to provide model. Previously, also, we were providing all these things. Previously, also, we were passing all these things. See this one, client. When I'm generating the client, which was the OpenAI instance, here also I need to provide base URL and APIs key. In LangChain, when I'm creating this LLM from this chat NVIDIA class, then once again I need to provide base URL and model. In addition to this, in addition to base URL and model, I am also providing the temperature. Temperature is another parameter. Actually, temperature is used for generating the some creative output. For example, the range of temperature is in between 0 to 1. If it is closer to 0, then we want very specific output. But if it is closer to 1, then we want some random creative sort of output is there. We can take one example. For example, like what is the capital of India? If this type of question is there, then we should be very specific in giving the answer. Here we do not want any creativity and all. If this is the scenario, then temperature should be closer to 0. Secondly, if it is a very creative answer, like for example generate a like creative short poem on some specific topic, in that case temperature should be closer to 1, because here we want creativity. Fine. Just run this. Now it is very simple. This is the prompt, and here we just need to call the invoke method. See, previously what we were doing in generating the response when we were using OpenAI API. See, when we are using this OpenAI API, then I need to write this much thing. Client.chat completion.create. I need to define model. I need to define messages. Okay. But here what I need to do, first I am defining this prompt. Who are you? And this is the thing but the result. I'm just calling the invoke method on LLM. Simply we need to call the invoke method on LLM and just provide the prompt. What is LLM? LLM is nothing but the instance of chat NVIDIA. That's it. In result, I got the result. Just look at the result. See, what was the question? Question was this: who are you? And to whom you are asking this? Who are you? I am asking this question, who are you, to LLM. LLM is generating this response. I am an AI model. Fine. Here, a lot many informations are there. If we are interested in content only, then we will get this content. This is the response generated by LLM. I am an AI model known as Llama or conversational AI. I am a computer program designed to understand and generate human-like text. I can process and respond to a wide range of questions, topics, prompt. Fine. This response is generated from LLM. Now you see the difference. Here what I need to do, just define the prompt and call the invoke method. Very simple. Call the invoke method and just pass the prompt. We can have some more examples. Here I am saying that give me 3 puns having to do with LangChain. Fine. This is the result and we are printing the content of results. Fine. This was LangChain. Any doubt or any query till this point? Okay. Next, we will have a look at streaming and batching. It is important in streaming. What do we mean by that? If you ask something to LLM, then it generates the response, and the response is getting like the response is printed, like getting printed also. For example, uh, if I am asking something like that is a 2-page content. There are two options. First, I should wait till the creation of the content of 2 pages, and then I can print that content. Secondly, what I can do, I'm just printing first line, second line, third line, and at the same time, the contents are getting printed also. So streaming means what? The content is printed as soon as they are generated. I am repeating this. Streaming means what? As soon as, the content is printed on the screen as soon as they are getting generated. It is called streaming. And what is batching? Batching means if multiple queries are there. If multiple queries are there, then we can just club all these into single query and we can call the batch method. This is nothing but batching. most of the things or the initial stuff are exactly same. For example, here we are importing this LangChain NVIDIA, sorry, chat NVIDIA. Then this is nothing but defining base URL and model. Then next one is this, where and when was NVIDIA founded. This was the prompt, and here we are printing the result. So NVIDIA was founded on April 5th, 1993 in Santa Clara, California, US. Now streaming the response. See here. This is the prompt. Explain who are you in roughly 500 words. Now see the content. This is the content. See, response is printed as soon as they are generated. Next, we will have batching. Batching means it is very simple. See, multiple queries are there. What is the capital of California? What is the capital of Texas? What is the capital of New York? What is the capital of Florida? Right? So multiple questions. It is nothing but simply one Python list. It is nothing but one Python list. Just run this. What is the name of this list? Name of this list is state capital question. State capital question. And here we are calling the batch method. We are calling the batch method on LLM. And what we are passing? We are passing this state capital question. Right? In capital, we stored the result. We can see length of the capital is 6 because 6 queries are there. And we can print the response. First answer is this. Capital of California is this, capital of Texas is that, capital of New York is this. Fine. All these are nothing but the answer or response generated by LLM. Okay. Which method we invoked or which method we called over here? This is the second method we are introducing, batch method. Before that, we had seen the first method, that is nothing but invoke. So far we have seen two methods that can be called using LLM. First one was like invoke, and second one is batch method. Next, comparison between batch and invoke performance. Comparison between batch and invoke performance here. So look at this. It is nothing but the wall time that I am printing using batch. What is the time? Wall time is this, 269 millisecond. 269 millisecond is that. Then we are having this. Here what I'm doing, calling multiple times that invoke method. So how many questions are there in list? 6 questions are there. So 6 times this method is invoked. Previously the time is 239 millisecond. Previously when we were using that batch, so the time was 239 millisecond. Time when we are not using batching and we are sequentially calling the invoke method multiple times, so the time is 1.36 second. See here, see the performance difference. And the reason between performance difference is that the GPUs, which are very powerful working in the backend. See, when I am having GPUs in the backend, multiple queries can be processed in parallel. But when we are processing the queries in sequential nature, then definitely we will get we will have more time. Here, next question is there. Here we are interested in generating this FAQ document. So for that FAQ document, we are having several questions. So FAQ, like frequently answered questions are there. Frequently asked questions are there. So first question, what is LLM? Second question, how do LLM works? What are some common applications of LLM? What is fine tuning in the context of LLM? Okay, all these are questions. How many questions are there? 1, 2, 3, 4, 5, 6, 7, and 10 questions are there. This is nothing but simply one Python list, right? This is nothing but simply one Python list, FAQ questions. Next is this. create FAQ document, it is nothing but one method. Here I am passing two things. First one, FAQ questions. We are having the FAQ questions. Yes, I am having the FAQ questions. I need to generate FAQ answers. When I am having FAQ answer, then both of these parameters, FAQ questions and FAQ answers, are provided to this definition, and it is appended in the zip format. Like FAQ document is initially empty. Question responses are collected from question and answer. First question is appended, then answer is appended. Right. This is the definition. Now, first one is FAQ answer that I need to populate. Now this is the solution. See here, multiple questions are there. Multiple questions are there in FAQ questions. So I need to call which method? I need to call the batch method. I need to call the batch method on this. So here I am calling the batch method on LLM, and I am passing these FAQ questions, and the responses are collected in FAQ answers. Response are collected in FAQ answers. Now I am having the response of all these questions. Fine. Now I can call this. I can define that method, and I can call this method. When I am calling this method, see here, the document is generated. This document will serve as a FAQ document. See, this was the first question. What is LLM? If you remember the first query here, first question was this: what is LLM, right? Second question: how do LLM works? So this is the first one. What is LLM? This is the answer. Second, how do LLM works? Then its answer. Likewise, second question, third, fourth, fifth, up to 10 questions are there. This will serve as a FAQ document. Any query or any doubt till this point? Fine. Now we will see iterative prompt development. What do we mean by iterative prompt development? See, we ask question to the LLM, like we just pass the prompt. Based upon that, the responses are generated. Now the response is completely dependent on the quality of the prompt and the specificity of the prompt. The prompt would be specific, then only we will get the proper response. Here, comfortable and process with iterative prompt development, understand the importance of prompt specificity. This is the thing that we need to understand over here. Same thing that we are doing, importing chat NVIDIA. These are some helpers functions are there. Here we are defining base URL and model. Now this is the prompt iteration example. What I need to do, I am interested in baking a cake. Suppose today is Sunday. I am interested in baking a cake, right? Now I am asking the to the LLM, what is my prompt? This is the first attempt, right? I am asking, tell me about cakes. If I ask this, like, tell me about cakes, so it is generating like this very very non what we can say, non beneficial kind of response. For example, see, it is just showing this cake history, cake culture. See, I am not interested in all this, like cake history and cake culture. I am interested in baking a cake. What was the first prompt? First prompt was this: tell me about cakes. Next attempt is what? Next attempt is this: tell me about baking cakes. Previously, what was the prompt? Tell me about cakes. This time, tell me about baking cakes. Right? This time, some more better response I am getting. But once again, I will try third time. Here I am asking how do I bake a cake? So much better response I will get now. But I'm not getting the complete details of this. Now see the last attempt. This is my last attempt. I want to bake a cake, but have never done it. I need step by step instruction for what to buy, how to bake the cake, how to decorate it, how to serve, and how to store this. I need estimated time for every step. I just want a list I can follow from beginning to end. See the specificity of the prompt. This prompt is very specific, right? If you look at the response of this, it's very beneficial for. It is showing me the complete. The thing is that fine. Okay. So now we will see prompt template. Now, what is the meaning of prompt template? See, there should be some template. Based upon that, I can generate the prompt. This is the meaning. Now, basically, here we will be understanding this objective of this. First, we will appreciate the need and ability to capture LLM related task in prompt template. Be able to create reusable prompt template with LangChain, and then fine. So all these things that I need to do. Just run this. Like import chat NVIDIA chat prompt template. This is new thing, right? I'm importing chat prompt template. Next, I'm having once again the same thing like base URL and model. This is the new thing like one-off task and reusable functionality. See, this time, suppose I am interested in multiplying 99 by 64, I will get the answer. Suppose tomorrow I need to multiply 98 by 63, then once again I need to write over here. So this is actually not very reusable things. If we talk about reusability, then we are having like normal functions in Python or in C language. For example, this is nothing but one function multiply two numbers, and here I am passing two variables a and b. So it is returning a multiplied by b. Here I am having this multiplication, multiply two numbers. So 99 and 64 are multiplied to each other. What I'm doing, I'm simply calling the function. I'm simply calling the function. When I'm having this function definition, I can call that function multiple times, like 100 times, every time with two new integers. It is called reusability. Now we will try to understand this reusability in the context of prompting. Now see one of prompt. What I'm interested in doing, translate the following sentence from English to Spanish. Translate the following from English to Spanish. Today is a good day. This is simple prompt. I'm calling the invoke method on this prompt and printing the result. It is giving me the translation perfectly fine. Now see here, suppose this statement is getting changed. Instead of today is a good day, suppose I need to write tomorrow is a good day, or I need to write day after tomorrow is a good day. Then once again, I need to change this again and again, this prompt. This is not reusability. Now I need to introduce this reusability with the help of function. I'm writing one function. What is the name of this function? The function name is translate from English to Spanish. Got Now see, Here we are writing one definition, the function definition. What is this function? Translate from English to Spanish. This is the name. And here I am returning this string. Translate the following from English to Spanish. Provide just the translated text. And here English statement. What is English statement? It is nothing but the formal arguments that we are taking into this function. Now, English statements. This time it is a list. Three statements are there. Tomorrow is a good day. Today will be even better. And next week we can say. These three statements are there. Now, from these three statements, I need to generate three prompts. So, what I'm writing, translate from English to Spanish. What is this? This is the function. Translate from English to Spanish. Here, English statement needs to be passed, but this English statement is to be collected from this English statements. This is English statements. One by one, statements are coming. We are calling this method and we are generating this result and the prompts are generated. So, three prompts should be generated. What should be the first prompt? Translate the following from English to Spanish. Provide just the translated text. Today is the good day. This is the first prompt. Second prompt will be translate the following from English to Spanish. Provide right, and we can. These are the three prompts. First prompt kind of solution. Here we need to write the map. Spanish version of first sentence, Spanish second one. Yeah. So this is nothing but the first version. Translation of first sentence, translation of second sentence, and translation of third sentence. Like, I hope that the things are clear. Now, this statements like translation is from English to Spanish only. But suppose I need to translate from English to French or Bengali to Gujarati or Bengali to French or Bengali to German. In that case, what I need to do? So I will just have another function. The name of this function is translate. Here I am taking three arguments. First argument is the value of from language. From which language I am interested in translating to language. Into which language I am interested in translating and the actual sentence which is given in from language. So it is giving me this string. Translate the following from language to language. Provide only the translated text and the statement is given. Then here I am calling the translate method. Look at this. Translate method I am calling English, French, and this is the statement. This will give me the prompt. On this prompt, I call the invoke method through LLM and then printing the content of this. So these things that we need to do, like we need to complete all these things with the help of function definition. Okay. But here we are having LangChain, which is a very sophisticated tool for all these orchestration purposes. Now, with the help of this LangChain tool, we will try to understand this chat prompt template and from template. We are having, we can have the template, and from this template, we can generate the prompt through LangChain. In this notebook, we have not seen like the things happening through LangChain. Now we will see the LangChain. Here we need to import this stuff. What is this stuff? Chat prompt template. First import this. Then from this chat prompt template, call this method from template. From this chat prompt template, call this method from template, and this is the template. Translate the following from English to Spanish. Provide only the translated text, and English statement is provided here. Right? The name of this template is English to Spanish template. When we when we are interested in generating the prompt, this is the difference. We need to understand the difference between English to Spanish template and this prompt. What is the difference between this English to Spanish template and this prompt? Yes, anyone, can you tell the difference? Like, what is the difference between English to Spanish template and this prompt? See, the difference is that the first one, which is nothing but this English to Spanish template, is a prompt template, and second one is nothing but the actual prompt. So what should be the flow? Flow is like that. We should first have that template. From that template, we should generate prompt. How can we generate the prompt from the template? How can we generate the prompt from the template? This is the question. We need to call the invoke method on the template. See, we need to call the invoke method on template. See, here we are calling invoke method on template, and we are passing this statement. What is this statement? It is expecting input in this variable, in this placeholder. The placeholder name is English statement. We know we want value in this English statement. When we are having value in this English statement, then we can have this translate from English, following from English to Spanish, provide only the translated text. Today is the good day. So these things are like that. Here we are calling the invoke method on this template, and this is to be provided. Now this will become prompt. When I am having the prompt, I can call the invoke method on LLM. Fine. This is the content. So I'm just repeating the flow once again. Flow is like that. From template, I need to call invoke method on template. I can generate the prompt. Once I am having the prompt, I can call invoke method on prompt through LLM, and I can get the response. Okay, next one, we are having the details of chat. Suppose I'm printing this prompt. See here, prompt is nothing but one message. Which type of message it is written there? It can be human message, it can be AI message. Human message means I am asking something to user, so it is human message. Then next is content. Like, what is the content of this message? Fine, all these things are there. You can just compare this with when we were creating or when we were generating the response with the help of OpenAI API. Next one, we will have a look at like prompt template for multiple values. So far we had seen that template with single input, but it is not the case. We can have multiple values as input to the template. See, this time we are having this English to Spanish template, chat prompt template from template, translate the following from English to Spanish, provide only the translated text. Okay, so this the English statement is provided over here. This English statement is provided. It is expecting only one input. This template is expecting only one input. What is the input? English statement. When I am calling invoke method on this template, I need to provide only one input, and it is considered that this input is corresponding to this English statement. Then I am calling the invoke method. I can also pass like this, like the value of English statement is this: today is the good day. Next, look at this template, like number 24, cell number 24. Here I am having another template, which is nothing but a chat prompt template from template. Here I am having this translate the following from. First placeholder is from language, second placeholder is to language, and provide only the translated text. It is the third placeholder, which is nothing but the statement. Now I need to call the invoke method on this template. So this is my template. I am calling the invoke method on this template, and I am providing the value of this. Like what is the from language? It is English. What is the value of to language? It is French. And what is the value of statement? Like that. So three values needs to be provided while generating the prompt from this template. Why? Because in this template, three placeholders are there. We need to provide the value of from language. We need to provide the value of to language. We need to provide the value of statement. Then only prompt will be generated. Once prompt is generated, I call the invoke method on LLM. Fine. I call the invoke method and just print the content. We can change this also, like French to, in place of French I can write Bengali. Fine. So similarity is that, similarity is what, like I can generate, or I can have this, I can call invoke method on template. I can call invoke method, two different things, but you just need to remember these things, because in the next part we would be having runnables and all. So we will understand that what is runnable and all in that case. Fine. Here one exercise is there, like create, need to define this. These are the piece of text. For each of these piece of text, we need to find out the sentiment, we need to find out the main topic, and we need to find the follow-up questions. Three things that we need to do for these five pieces, right? So what I need to do, first I am having sentiment template. So this is nothing but the sentiment template. Here just I am writing in a single word, either positive, negative, provide the overall sentiment of the following piece of text. This will become my sentiment template. Similarly, we are having main topic template. Identify and state as concisely as possible the main topic of the following piece of text. Only provide the main topic and no other helpful comments. Then third one is this follow-up questions, follow-up template. So this is nothing but the follow-up template. What is an appropriate and interesting follow-up question? Fine. This is the third template. Now these are three templates are there. Now I need to generate prompt. Generate the prompt from the template, because see what is the flow? Flow is that from template prompts are generated. Once prompt is generated, they are given to LLM. Now initially nothing is there in this. Now we are having this cell. Here we can say, here I am calling the invoke method. Here I am calling the invoke method on template. See total how many statements are there? 5 statements are there. So here 5 times it is called. So this will become my sentiment prompt. This will become my main topic prompt, and this is nothing but my follow-up prompts. From these three templates, I have generated 3 prompts, right? In sentiment prompts, total 5 prompts would be there. In main topic prompt, again 5 prompts would be there, and in follow-up prompts, third like 5 prompts would 5 questions would be there. Now answers. I need to find the answers from LLM. So initially the sentiment is nothing but the response collected from that first regarding sentiment, main topics, responses collected from like for main topics, and follow-up responses collected from follow-ups. Then see here, I can invoke the batch method and just provide the sentiment prompt. Then I can invoke the batch method on LLM by passing main topic prompts. I can invoke the batch method on LLM by passing follow prompts. Right? So these are the 3 things. I have provided sentiment, main topic, and follow-ups. Now for each of these text, the structure. First, that statement should be there. After that, the overall sentiment of that statement, then main topic, and then follow-up question. Then second statement would follow. This is the result. See, first that statement is there. I had a fantastic time hiking up the mountain yesterday. Overall sentiment is positive. Main topic is hiking and follow-up question. What made the hike particularly enjoyable for you? I hope that this point is clear. Then second point or second statement is there. After that, this is the three things remaining. Fine. And this is nothing but the summary. Any query or any doubt in the first part? Okay, fine. So this was the first part. Now we will see the second one. Second part is related to chains. First section introduction, then 21, 22, 23, and 24. We will try to understand this one by one. After completing the second part, mostly we will stop and then we will continue like tomorrow. Now see. So this is nothing. LangChain expression language LCEL, runnables and chains are there that we need to understand. This is the table of content. Notebook number 21 talks about LCEL. Notebook number 22 talks about runnable. 23 talks about combining chains and 24 talks about parallel chain. Now first we will have a look at LCEL and chains. Here we need to understand this. Understand LangChain runnables and as unit of work as LangChain. So far we have seen that on LLM instance and on prompt template we call the invoke method. They are considered as runnable. The next one we are having create and use runnable output parser, and we can see compose runnable into LangChain chain using LCEL pipe. First we need to import this thing like chat NVIDIA, chat prompt template and string output parser. After importing all these three things, we are having these models, base model, base URL, model and LLM. Then next one is this LangChain runnables. So here it is nothing but chat prompt template from template. Here I am asking this question, answer the following question, and this is my question. It is there in template. It's there in template. So I can call invoke method on this template and I just need to provide the value of question. Fine. I can call invoke method on LLM this time. So for generating prompt from the template, I need to call invoke method. For generating response through LLM, I need to once again call invoke method on LLM, and see this is the response. Next, these are actually the runnables. Runnables are nothing but a piece or unit of work on which you can call these functions for these methods, for example, invoke, batch, etc. Okay, suppose these are the three questions. These are the three questions. So I need to call the batch method on this template. I can generate three prompts. So these are the three prompts. Then next one is this LCEL, which is nothing but LangChain expression language. So with the help of pipe symbol, we can just club these runnables. So here we are simply introducing one chain. We are simply introducing one chain. So this is chat NVIDIA. In this we are passing base URL, model and temperature. This is chat from template. So LLM and template we have provided over here. Now I am just clubbing these two things, template followed by LLM. If you remember that these two runnables are there, like template is also runnable, we can call invoke method on template. LLM is also another runnable, we can call invoke method on runnable. When I call invoke method on template, then I am having the prompt. When I am calling the invoke method on LLM, I generate the response, right? Here I am clubbing template with LLM. First template is there and second LLM. Thing is that first prompt should be generated. That's why first I need to write template. It should not be like that template followed by it should not be like that LLM followed by template. It should be template followed by LLM. Then we can have the ASCII graph for this. So this is nothing but the ASCII graph in which you will see this structure. First prompt input is there. On this prompt input, we are having this chat prompt template. Then chat NVIDIA is there. After that, chat NVIDIA output is there. Then next one, I am having this input schema. Here we can say required field is this question, because if you look at the prompt template, if you look at this prompt template, is this. So here only one thing that I need to provide, the value of this question. The value of this question needs to be provided, right? Okay. So next one is this, like chain.invoke. Here the question is this: who founded NVIDIA? Who founded NVIDIA is nothing but the question. See, this is the response. So we can just generate the response. NVIDIA was founded by Jensen Huang. Now look at this. From this was the actual content which is generated. From this content, actual answer is there along with some metadata information is there. From this answer to this actual answer, I need to pass, or I need to write like this, like answer.content, then only I will get the exact answer, and other metadata information is not printed over here. Instead of that, what I can do, I can have some output parser. I can have some output parser for which I have not, I need not do all these things like answer.content printing and all. So this will become, first we need to import string output parser. Then it is nothing but the instance of this parser. The parser just parse, for example, string is given. So it is just parsing this string. Multiple strings can be provided. So it is generating the list. Now we are concatenating or clubbing these three runnables. First one is template. From this template, we need to provide the value of the question, because one placeholder is there, which is nothing but the question, needs to be provided into template. Uh, then second one is nothing but LLM. Once question is provided, the template will generate the prompt. This prompt is given to LLM. LLM is generating the response. Response is given to parser. Parser is generating the outcome. This is the flow. We can have the ASCII graph for this. First prompt input is there, then chat prompt template, then chat NVIDIA, string output parser, and its output. Only one thing that I need to provide the value of this question. Who invented the use of pipe symbol? Fine, this is the question. Here, this is the response generated. Like, I do not have any information on who invented the use of pipe symbol in the Unix system. Next, translation is revisited this time. This time, look at this template. Chat prompt template, like from template, translate the following sentence or translate the following statement from. So this is nothing but first one, from language we need to provide. Second one, to language that I need to provide. And the third one is nothing but the provide only the translated text, and here we need to provide the statement. This will become my translate template. This will become my translate template. So this translate template is concatenated with LLM and then parser. So in this translate template, how many inputs are expected? Three inputs. First, I need to have this input from language. I need to have the second input, which is this to language, and I need to have the third input, which is nothing but this statement. Which are the required field here? Required three fields are required: from language, to language, and statement. When I call the invoke method on this chain, I need to provide these three things. Instead of this German, if I write Gujarati, fine. So this was LCEL. Next, we are having runnables. Any query or any doubt in LCEL? Okay, now we will have the runnable functions. Here, these are the objectives. Understand about the custom runnable functions and include them in your LangChain chain. Then we can use the runnable functions to pre-process the data before sending it to LLM. Then we can have custom function to batch translate the raw text into prompt template. Then create a LangChain sentiment analysis chain utilizing multiple custom runnable functions. Here we are importing this chat NVIDIA, then chat prompt template, string output parser, and then runnable lambda. Okay. Then it is nothing but the model instance. Here base URL and model is provided. Then we are having this runnable lambda to create the custom runnable functions. So first we are importing this runnable lambda. The purpose of this runnable lambda is this. For example, if I say that double is simply a function which is just doubling the integer. So it is twice x. But if we call the invoke method on this double, so it will give me the error, because invoke method can only be invoked, or invoke method can be called on runnables only. But double is not runnable. Double is a simply Python function. So any Python function can be converted into runnable by just applying runnable lambda on that function. Any Python function can be converted into runnable by simply applying that runnable lambda on that function. Here we are applying runnable lambda on the function, and we are generating this runnable double. On runnable double, we can call the invoke method. We can call batch method also, right? We can club all these runnables with the help of pipe symbol, because we know that runnables can be clubbed and we can form a chain. So runnable, one runnable double will be multiplying it by 2. Second will be again multiplying it by 2. So cumulatively it will be multiplying by 4. Then one more multiplication by 2 will give me multiplication by 8. When I am passing 11 to it, it will give me 88. Fine. Next, we are having this data management. So what do we mean by that data management? For example, if I need to do some normalization on that data, import re and import contraction. So this is nothing but the normalized text. And here text are provided as input. So this is nothing but text is equal to, we are just converting the text into lowercase. It is simply the Python function. Whatever text I am providing, suppose one paragraph is there. That paragraph is second thing, and after that remove extra white spaces. So these are the three pre-processing to be done on that paragraph. Then next one is this. These are the various methods. First method, second method, sorry, first review, second review, third review, like that. So what we are trying to do this time, we are combining these things. These reviews are there. So first we just run this reviews. What we can do, we first convert that normalized text. What is that normalized text? This is converted into runnable. From this to this, on this runnable we can apply batch method, as we are having multiple reviews. Look at this, total how many reviews are there? 5. Fine. So this is the answer. Next, we are having this like formatting text for prompt template. Uh, Text can also be formatted for giving input to templates. For example, this is nothing but the normalized reviews. I have collected this normalized reviews from here. Fine. This is my normalized reviews. Then here, chat prompt template. Prompt template is there. Here, we need to write this. In a single word, either positive or negative, provide the overall sentiment of the following text. You provide this text. This is my sentiment template. And then sentiment template dot invoke. It is called over here. And this is nothing but this type of content is generated. Next, we are having like preparation for sentiment template. So here function is there lambda. This type of text should be printed like text colon the value of text. This type of format is required for preparation of sentiment template. Fine. And once we are having this preparation for sentiment template, then I can call the batch method on this. This is nothing but the batch method. Text followed by this first sentence, text followed by this second sentence, because sometimes we may be interested that this type of pattern like dictionary like structure should be followed for this. Then next, create a sentiment analysis chain. This is nothing but the exercise. So it is very simple here. So we are defining the output parser, and after that first thing that we are doing, we are just converting that normalized text into runnable. It is given into preparation for sentiment template. So this was runnable. Now we will have a look at combining the chains. This is actually important. Here it is getting some time to load. By that time we will have a look at how can we combine the chains. Learn how to compose chain of chain. Apply your ability to chain meaningful language task. Here see, we are importing this chat NVIDIA. Then chat prompt template, string output parser, runnable lambda, and runnable parallel. This is nothing but we are creating a model instance. Then next one is combining multiple LLM chains. So here thesis statements are there. Multiple thesis statements are there, like first statement, second statement, like that. So we need to do some fruitful things from here. Exercise is this: create a spelling and grammar chain. First, we need to create a spelling and grammar chain here. So this is nothing but the grammar chain. See, chat prompt template, from template, fix any spelling or grammatical issues in the following text. Return back the corrected text and only the corrected text with no additional comment or preface. Here, this type of text is provided: text colon text. This is spelling and grammar template. By parser is there. This will become my grammar chain, right? And after that, I can call the batch method because multiple statements are there in this thesis statement. So this is the corrected text. Now I can print all this corrected text over here. Right? See the fundamental concept of quantum physics. Look at this. What was the sentences given here? Here the fundamental concept quantum physics of was missing. So it has just removed all the grammatical and syntax error. The concept of quantum physics, the fundamental concept of quantum physics are difficult to grasp and all. Fine. Second chain that I am interested in preparing is create a paragraph generator chain. This is the second chain. What do we mean by this paragraph generator chain? Now look at this. This is the chain. This is the template, like chat prompt template, from template. Generate a 4 to 8 sentence paragraph that begin with the following thesis statement. Return back the paragraph and only the paragraph with no additional comments or preface. Here thesis statements are provided. From each of these thesis statement, we need to generate the paragraph such that first sentence or first statement is that paragraph itself. First sentence of the paragraph is that sentence itself. Paragraph generator template is given as input to LLM and then parser. Fine. Now we can call invoke batch method on thesis on paragraph generator chain, passing it thesis statements over here. Now we are printing these paragraphs. Yes. So we were looking on these thesis statements. For each of these thesis statements, we are generating the paragraph. So this is nothing but the second chain, which is nothing but paragraph generator chain. See here, this was the paragraph generator chain. We just need to write generate a 4 to 8 sentence paragraph that begin with thesis statement, return back that paragraph and only that paragraph, like without no additional comments or preface. Then paragraph generator chain is given to LLM and finally to the parser. Finally batch method is applied on that paragraph generator chain by passing thesis statements as input. and these are the outcome which is generated. So for each of these thesis statement, one paragraph is generated such that first statement of that paragraph is that statement itself. Now we need to create chains. So far we were looking that we are just clubbing the runnables to form a chain. This time we will see that multiple chains can also be clubbed. For example, see, here we are generating clubbing two chains. First one is grammatical and spelling mistake removal chain is there. First grammatical and spelling mistake should be removed, and then it should be given to paragraph generator chain. So we are calling the new chain as corrected grammar chain. Fine. So likewise, we can just club all these things. First thing, we can club the runnables to form a chain. Then we can have multiple chains that can be clubbed. So on runnable, we can call invoke method, batch method, stream method. On chain also, we can call it things are there in the context of LangChain. First, we have seen LangChain expression language, then runnable, and then combining chain. So this was most of the things related to runnables. Any query or any doubt? Okay, so we can stop over here. If no doubts are there, then we will meet tomorrow once again. Thank you.